Well, we appreciate you guys joining us today. This interagency briefing is about zero trust, but we're actually going to dive into something that deals with the identity side of things and bias testing. We're going to talk about that more today because that's one of the hottest topics, right, guys? Saw that in the news, challenges as well. So we're going to talk about that, right, Charles?
Absolutely. We'll go into a lot of detail on that.
There you go. So we will talk about that as well. So we appreciate it. And we want to welcome everybody. This is truly an interagency briefing. We have dozens of agencies here. So we know that you have plenty of things that you guys can do. And joining us today, obviously, zero trust is a big deal. It's one of the things that's driven down by the president. And when the president says to do it, we got to get it done, right? So here we go. This will be the best briefing ever. Mark from NASA says agencies could share what they're what they're developing with their zero trust reference enterprise and solution architectures. Love that idea. Michaela, I think that's how you say that. From this, cloud services will be discussed from the federal consumer perspective. All right. How to determine the cloud solution, implementing it. I like that idea too. I don't know that we'll talk all about those pieces, but we will. I just want to make sure you guys know what we're in for. Right, Charles? Right, Paul?
You got it. We'll be talking about it.
Yeah, that's right. And Barbara from Census discussing actual approaches for CTA instead of just concepts. Imagine that, Barbara. That'd be great. Implementation and give examples of implementations for all 5 pillars because there's multiple pillars involved. We know about that. Some say 5, some say 7, some we don't know. But anyway, we'll talk about that later. Demetrius from FCC, facilitate understanding how to right size continuous authorization. That's an interesting one. You guys, you want any of these you want to take beforehand or tell them that it's out of scope? We may be able to talk to you later about that, Demetrius. And we'll make sure you have the opportunity to do that. Miriam from FEMA, I understand something new by the end of the briefing. First thing you know, Miriam, is Costco pumpkin pies. Sheila from the VA, although a thorough explanation of what this is and why it's important occurs. I think we will do that. Another one, Carrie from FEMA. If there's an interaction with the audience, hopefully that's true, Carrie. We'll make sure we do that with you. Robert from the SEC helps to enhance understanding of identity management within public-facing .gov systems. Woo, that's a mouthful right there, isn't it? Isn't it, Charles? Douglas from VA provides best approach for success. I hope you find something new because one of the biggest challenges is trying to figure out how to do it end to end, and Resilient has a way to do that, and that's why you're here with Resilient. Leon from Inspector General's office, real-world examples of planning implementation are discussed. Love that idea. Jacqueline, we have clear, concise understanding of ZTA and how ZT strategies can improve security and risk management. That's the whole idea, right? To improve security and risk management all rolled into one. Love it. Scott from USCIS. We can all stay in touch and share lessons learned and work together as we implement ZTA. Love that. That's one of my favorites. Hopefully we can do that. And we have the ability to share that information with each other. Absolutely. Grace Marie from the VA. You can address the pitfalls. No pitfalls for ZTA, guys, right? None at all. To implementing ZTA and an environment with several different independent contracting units. That's a big problem, right? When you have disparity around your units. So we appreciate all of those. You will have access to session docs. In fact, boom, right now, they're probably going to magically appear in the chat. You'll have access to the presentation, presidential order, ZTA technology stack, a couple of other things that you can also take a look at as far as case studies for how this is being used, especially as we're going to talk to in specifics about the bias testing or identity bias as you deal with race, especially people of color, right, Charles? That's a big deal.
Yeah.
But that also includes age and gender too, doesn't it?
Yeah, you got it.
Yeah. Fantastic. So if this is your first Zoom, can't imagine that's the case, but you can go up top there and you can select side by side, make bigger, smaller, whatever you'd like to do. We will be sharing information. We'll have a couple of polls and things to get to get a pulse of where you guys are. But more importantly, docs are going to be put in the chat because I think we have 70 folks here. So in order to maintain some sort of order, we'll pop all the docs in the chat, and whatever your favorite Thanksgiving food is, that's what goes into the chat. And if you have any questions, please raise your hand. We're talking about interaction and making sure that you get what you need out of this. Raise your hand, put it in the Q&A. If you have private dialogue, write down, do yourself a favor, write this down, dbeloche@resilient.com. And if you have something that you don't want everybody to see, shoot that over to Daniel. He's here. He's the tall, dark, and handsome man behind the scenes. But he'll be able to answer those questions for you. Get it to the right people, right, fellas? Perfect. And so quick disclaimer, and this comes from GSA so that we all can talk. So it's not an endorsement or a commitment to purchase from any vendor. This way you can actually dialogue, and the IG's office is not going to get irritated with you. How about that? So now we'll get into the nuts and bolts of this. So why did you guys decide to join us today? Are you trying to get your head around ZTA? Or you're in the hot seat for implementation of ZTA? There's a lot of folks here. We saw some of the pieces coming in for what they were looking to accomplish here, guys. And there are folks that are on the hot seat for that. You can pick as many as you want on the top part. And looking at ZTA to solve a current security issue, probably true. Or your boss made you come, and you can be honest here about that. So we love it. I knew there was going to be some Weisenheimers that would say that. So for those of you who have been to GovBrief before, thanks for joining us. And if you're first time, hey, we love the fact that you join us as well. Thanks for doing that. And we'll keep that open for just a minute while we introduce the folks here from Resilient. We have Charles and Paul and Daniel both are here, but Charles and Paul are going to be taking the lead on this. Charles, introduce yourself and tell us a little bit about Resilient and how you guys got started.
Well, I'm Charles Ambuel. I'm the Chief Product Marketing Officer of the company. We're headquartered out of Miami, but have various offices throughout the United States. We have been the result of a merger of two important companies. One was the original Waverly Labs that did an extensive amount of work initially developing and assisting in the SDP, software-defined perimeter initial projects with the Cloud Security Alliance, but also the merger with ID Please, which has brought to market an incredibly robust identity credential access management tool that we now refer to as Resilient ID, which we'll be getting into much more detail on. Okay.
Well, that's fantastic. And Paul, what do you do besides look great on camera?
I do the heavy lifting. I am the VP of engineering for our new merged Resilient company. I take care of the engineering duties and the overall direction of the zero trust portion of the solution.
Love it. And I really appreciate you guys being here because it's a big issue. We had, I think there's over 140 people that are actually registered. A lot of folks said that they couldn't make it, but because it is being recorded, it'll be distributed. How about that? But we're talking about what is zero trust, the key issues that in being able to implement, what do you need to address, and the problems you're likely to encounter. And we know that a lot of agencies are encountering problems, not the least of which is that identity bias we talked about earlier, right, Charles?
Absolutely.
So, and we'll give you a quick demo, high level demo of how the system works so that you can see what an end-to-end solution looks like, because a lot of folks don't even believe that you can do it, by the way, just saying. So we're going to end this poll in 3, 2, 1, and boom, there you go. So let's take a look. A lot of folks here trying to get their head around zero trust, right? And there's a few that are on the hot seat. So we love that. And security issues are always a problem. And we got a bunch of folks that are back. We really appreciate that. Thank you so much for joining us on that. And we'll get rid of that for you guys. And let's get right into it. What is this zero trust? For folks that are new to this as an environment, what is this? Who's taking it? Charles?
Okay, zero trust is really an architecture, a very comprehensive architecture that the government has initiated a framework to be able to, for all the federal agencies to be able to understand the various components that go into a zero trust architecture, to be able to understand what they need to be able to address the security requirements that they specifically have for their environments.
And so when you look at these models, there's a lot of people just don't understand what it means. But so what we're talking about here is the never trust and always verify thing. So can you take us, what does that mean exactly?
So the true main concept behind zero trust is that you can never trust anybody that is attempting to try to gain access into your network, into your secure solutions.
But Charles, I'm a trustworthy individual. I should be able to see everything. I don't understand.
Very trustworthy, but
very trustworthy.
How do we know you are who you say you are?
And there it is, right? So the biggest thing is to be able to say, making sure on both sides, right?
Yeah.
So one of the pieces that we talked about in the last briefing was, hey, you don't need to just know that I am who I say I am, but I need to make sure that whoever I'm talking to in the government side is also who they say they are, right? So let's talk about some of the key issues that you have.
Well, the key issue that we just really laid out was that zero trust is a comprehensive architecture, and we have a graph coming up shortly after this that will go through the 7 pillars that the federal government has really articulated in detail across what we refer to as the full end-to-end zero trust issues. It addresses everything from the end user. Again, repeating myself, we need to absolutely identify the user, that they are who they say they are, that they're going through various checkpoints in the network to verify that they're connecting from the right device, that they're, maybe we can perform geolocation, that they're connecting from the right geolocation aspect. They're not in Russia. That the applications and assets that are of high security to the organization are being highly secured and are protected by a zero trust zone. And the ability to be able to create these trust zones for the various types of assets that the organization has, to be able to only allow those authorized users to be able to be accessed into those applications.
Yep. And you're going to talk a lot about trust zones, because that's exactly what this whole model is. And if this doesn't blow your mind, if this is the first time you've seen anything like this, this is actually where's this come from?
I've heard various stories, but we're a member of ATARC, which is a federal and commercial entity that is trying to put together and ensure organizations that are attempting to provide security solutions to the federal government meet certain capability requirements that the federal government has stated. What we have here is the 7 core pillars, going from user, device and endpoint, the network environment, application, workload, data, visibility and analytics, automation and orchestration. And across those pillars, there are a number of different core capabilities that are identified for at least, the first 2, what we refer to as ICAM, the Identity Credential Access Management portions, where Resilience, Resilient ID product addresses the vast majority of those capabilities. As we move from left to right, going through the network, through the application and data, that's where our zero trust application is being implemented, and its capabilities being able to address those aspects going to from the end user, connecting to the zero trust zones, and being able to secure down the data and applications for the organization. The green represents those core capabilities of resilience, end-to-end zero trust. The yellow is indicating those things that we integrate with. We have a number of RESTful APIs that we can provide data to be able to ensure that your CM and other applications are receiving appropriate information to be able to make those types of security decisions based on the information that we can provide them. Identified in purple are items that are on our roadmap right now, and those that are in blue are not core capabilities of our application, but there may be some implementation capability later on, either through a vendor or some type of solution that we may come up with. But those are not core elements that are part of our capabilities today.
Right. But even so, you're going all end to end from the user all the way through all of the delivering the application and making sure that's secure across the board. Is that what I'm seeing there?
That is correct, Dave. The front end where the Resilient ID is, we have put a significant amount of effort into ensuring that that is very robust and secure, and we'll get into much more detail on that. But utilizing what was originally developed as the software-defined perimeter, utilizing gateways and controllers, and creation of zero trust zones, which is what Paul's going to be getting into in much more detail. That falls into the network environment, the applications and workload, as well as the data itself. Visibility and analytics, those are monitoring capabilities that we interface with, and certainly we are following all API standards to be able to facilitate automation and orchestration of the environment.
Sure, and now you can see why folks are having some issues making sure that everything works. So let's get to the fundamentals. There's 3 essential elements. Tell us about that.
So when we look at being able to secure down an organization's environment, the first item is that they need to be able to have an incredibly robust ICAM, or identity control and access management solution, in place. Mm-hmm. Following that, there needs to be the ability to be able to have a deny all access capability against what is securing the assets of the organization. So a zero trust gateway. And then to be able to communicate properly to the gateway as to who has access to what, under what conditions. A zero trust controller is necessary to be able to have that, and certainly an administration of all those capabilities together to be able to ensure everything is harmoniously working together.
Yeah.
And to add what Charles just said, those last 2 are essentially our enforcement points. Our data policy, our security policy enforcement point is the trust gateway, and the trust controller is our definition point for our policy.
All right. So this is what now, there's a lot of different ways that folks are addressing this and trying to address it. So right. I'm not going to ask you to talk about everybody else's, but you have a specific way of making sure, establishing your trust zones, as well as, and I'm really interested in how do you make sure that you're looking at the right person, that person is the right person that's accessing that? Take us through this model here.
So the on the lower left-hand side there, we have the Resilient ID. It's a very thin app. It's installed on a mobile phone, and it will provide the ability to be able to ensure that the user who is attempting to try to gain access into the system, requiring a selfie of that individual, but also prior to that, a very robust onboarding process that creates a very unique digital ID that we refer to as ID and FT. It's trademarked and is patented at this point. And it's stored in a private blockchain. It can be stored in a private blockchain within an individual federal agency, or can be stored outside of a federal agency. But that's important to understand, that the blockchain is storing this information for access later on to be able to do verification of that user. So that that initial selfie of the individual enables him to take, once verified, enables him to take the next step in being able to log into a system. And I'll let Paul take it from there, going through the Zero Trust Gateway and controller and trust zone.
Absolutely. So once we know for sure you are a person and you're alive and you've been onboarded, so we know who you are, then basically we need to know what device are you using to access those protected applications or assets in our trust zone. To that end, we also use what we call the single packet authentication technique to actually send a single packet to our gateway that contains the encryption keys and certificate information for the end user device. And and this is another onboarding event where we've previously onboarded the user's device, or the device that the user will be using to access those services. And we have that information stored in our controller for policy definition. Once we have that information, we know for sure that you are the device that you are, and we've passed along the credentials that have been verified by our Resilient ID portion. And we then go and make sure that you are part of the organization that you're trying to access. It's okay that you're alive. It's okay that you've been onboarded to our system. It's okay that we know that you are you. But unless we know that you are part of the organization that you're trying to access, we don't give you access. So then that's the third part. And then finally, we define a policy for what you're able to access, whether or not you're able to access certain services or even certain trust zones. We determine that by policy, again, at our policy definition point on the controller. And then we push that down to our policy enforcement point, which is at the gateway, to ensure that only those people who have been trusted or have been trusted and verified can get through to access to protected applications and assets.
And they don't even see that even exists, because it never even gets into the system. Is that what I'm seeing here?
That's correct.
From the outside, you can't even tell.
That's correct. The idea is you can't hack what you can't see.
That's right.
So that basically we hide the whole infrastructure, the trust zone, behind the gateway, such that even if you try to do some reconnaissance or try to do some snooping around what ports are open, et cetera, that comes up with zero. And that's what one of the whole ideas about that deny all firewall that we mentioned in the previous slides.
Very cool. Very cool. So let's talk about some of the problems that folks are encountering right now.
Well, to be absolutely certain that the end user trying to gain access into a system is truly that end user. Can it be faked out? What are the possibilities that that user is not the real user trying to gain access? And so, that is an incredibly important aspect. You need to be absolutely certain the end user is attempting to gain access to a trust zone is in fact the individual that needs to be able to gain access. How do you establish and create trust zones? And specifically, the old usage of VPNs and firewalls are not really a zero trust solution today.
Yep. Right. And unfortunately, that's where we live pretty much, between VPNs and firewalls right now. So
correct.
So let's look at this. So you're going to give us an idea of how this, what the system does and looks at. And I specifically, because I know there's folks here that really want to know about the bias side of things, right? So you're going to take us through these. How do we? We'll run through a couple of slides first. Is that what we're going to do? And then we'll hop on it.
Just to kind of set up the demo, we're going to do two demos on the end user side. One is the onboarding process, which is, I think you'll find very, very robust, very secure. And then the follow-on user access that somebody would be attempting to try to gain access into a system, which is a very strong verification, authentication for subsequent access into the network. I'll let Paul talk about the trust zones here.
Yeah, and as far as creating the trust zone, it's boils down to your architecture or how you want to protect your assets and your applications. We basically just established the trust zone using architecture, basically micro-segmenting, if you will, the network such that the assets are indeed only reachable through our policy enforcement point, our gateway. And then we set up the access such that the trusted users from the trusted devices are allowed to access those assets in the background. So it becomes a architectural thing as far as routing and networking is concerned. But then at the end of the day, you really have to define the policy for who you want to access those and who and what devices are they allowed to come from.
Love it.
As we talked about, onboarding is the fundamental first step of ensuring the security of users within the zero trust architecture. And I'm not, this is a lot of words, but
don't read it.
the activity that takes place here from a user standpoint is that, and they need to be able to take a picture of a government document. It's either a driver's license or a passport. It could be a company ID. It could be a agency's identification card that we have processed. We are able to currently test against a database of over 11,000 documents for authenticity. We need to ensure that there's no forgery going on. And we also need to make sure that that document has an actual picture of the individual on it. Mm-hmm. Second requirement is that the individual takes a selfie. We perform extensive liveness testing. We ensure that the individual in front of the camera is actually a live person. There's no deep fake going on. There is no picture being presented in front of the camera to try to fake out the identity of the individual. This process, liveness, has gone through extensive testing through a NIST lab, iBeta, and has gone through over 1,500 tests and proven that they've had a success rate of 0 in trying to fake out our liveness capability of our process. Nice. Bias tests are also applied for age, race, and gender. And we have been validated by another NIST lab. This is Bixby Labs, and have passed all of their bias tests in a positive manner. So that we show no bias whatsoever regarding the individual in front of the camera.
Which is, this is one of the biggest things since the last time we had a briefing back in August. That was one of the biggest things that came out and hit the news and everything about just the inability for the systems to handle, especially folks of color, and dealt with age, and you mentioned earlier that's in gender as well.
Gender as well.
Yeah. So just making sure that the system can handle all that, and yet still not be able to be faked out. That's an interesting thing. We do have a question real quick. We may get to this later. If you want me to, we can pop it to the end. Annie Sokol's asking, does NIST SP 800-63X align considered in the architecture?
I'm going to defer to Paul on that one.
So to an extent, obviously we don't cover everything that's in 800-63, but basically we can comply to a majority of it based on what we've done and the analysis we've done up to this point.
Awesome. And then David just asked, so your solution handles end-to-end and machine level authentication and verification?
Correct. As Charles just went over with the ID portion, the end user portion, that's taking care of that in that method, and it's very exhaustive, as you can see, and we've been certified through several, or at least 2 labs that NIST gets behind. The other part is the SPA packet, the single packet authentication, which we use to authenticate the machine that the user is actually using.
And I think Humberto is going to pop us right into what's going to happen in just a minute. How do you configure the safe zone, ZT, and the policies of each segmentation of this network? Great question.
Yeah, it's just, again, it's down to architecture. Everything that's behind a gateway is what we call a trust zone, but I understand you mean safe zone. So our trust zones are defined by our gateways, and we can scale laterally and also horizontally, or vertically and horizontally on that. So every time you deploy a gateway, you have created a trust zone, and everything behind that gateway has no routable IP addresses, so you can't reach through them through any other method but through our gateway. And that's how we establish that trust zone.
And so David's asking, how do you hide the apps behind the gateway? What protocol is the gateway listening to?
Well, as we mentioned before, we're implementing a deny all firewall that automatically hides everything that's on the machine, on the gateway machine, and what's behind the machine. To open up that capability to allow you to access that, that's where the SPA packet comes in. We actually authenticate the device and we authenticate the user. And once that's matched up against policy, we then allow access to the requested service or services for a small window of time to prevent anyone from actually taking advantage of those accesses being open.
All great questions though, right, gentlemen? Those are winners.
Yeah. Unfortunately, kind of jumping over where we are in the onboarding process.
We are definitely going to get there.
Well,
so,
we haven't actually, can you go back to the previous slide, please?
Oh, sorry.
Because the onboarding process is extremely important. I just want to make sure everybody understands the thoroughness that takes place here. Once the selfie, the user has taken the selfie, we compare the selfie picture to the government ID picture that was taken to try to make sure we can provide a positive verification, a match. If we identify a match of the two, then we know the person attempting to be able to onboard is in fact the real person. The next activity is we extract the UUID off of that cell phone and potentially the geolocation, which is the closest cell tower to that individual, as well as other key characteristics of the government document, the state, the city, the family name, any other features of the picture of the individual that was just taken. We take the geometry of the eyes and the nose and the mouth and the ears and the chin and so forth. And all that information is then thrown through a very important algorithm that creates a unique string. The string is then hashed using SHA-256. The resulting hash is what we have identified as an ID NFT. Again, it's trademarked and patented. We then store that in a private blockchain for future access and verification of the user to be able to gain access later on. We also store the original government ID on that user's cell phone, encrypted using AES 256. And the original government document is only stored in an encrypted state on the user's phone, nowhere else. We give complete control over the user of their privacy and personally identifiable information. Nothing other than a hash is stored on the private blockchain.
Love it.
Okay. The details of the authentication process. This is any access attempt after somebody has been properly onboarded. Again, the user takes a selfie, the liveness and bias tests are applied. The Resilient ID application on their device decrypts the original government ID that was previously stored. We create a local hash of the user's device using the original document. We also take the UUID of the user's device and key features of the individual selfie that was taken. We then create the local hash and compare that to the hash on the private blockchain. If there is a match, the user will then be positively verified and authenticated and allowed to move to the next step of being able to gain access into the system.
Love it, love it. So we're going to switch off here, and somebody else is going to take control of this screen in just a second. But while this is happening, we're going to ask, where are you on your journey of ZTA? And if there's anybody that picks that last one, we're going to say probably liar, liar, pants on fire, but we'll say it nicely, right, guys? So with that, can you go ahead and I'll stop sharing here.
I'll take it,
Charles, and then you can start sharing, and we'll find out where folks are. Love it. Love it. Thanks for
onboarding of the Resilient ID is a very simple process. The onboarding is performed once and takes less than 30 seconds. We create a unique blockchain digital ID, and we don't upload any information of the user or the government document to our secure private blockchain servers. And again, these can be agency servers as well. It equates to no risk of no hacking. 100% respect of the user's information and 100% security. The blockchain-based ID is called an ID NFT. It's trademarked and patented because we share with the NFT non-fungible token the same security characteristics: unforgeable, unique, indivisible, and interoperable. Non-fungible means that it's unique and can't be replaced by anything else. For the Resilient ID onboarding process, again, it's very simple. The user initiates the Resilient ID app. You are immediately asked to provide a government ID, a driver's license, passport, or other government ID with photo. Once you've selected the ID, a passport in this example, you place the phone over the passport, fit the document into the frame, and wait for the border to turn green. Resilient ID detects automatically the type of document and if it contains a chip. You will then be prompted to place the phone over the document as it's shown in the animation and wait until the chip reading process is completed. Next, you'll be prompted to take a selfie. Once Resilient ID has examined the photo for liveness and bias tests and validates against the government ID photo, determines you are who you say you are, a unique blockchain digital ID called ID NFT is created and uploaded to the secure private blockchain. That's the onboarding process. Verifying after a user has already onboarded. It's a very simple process with Resilient ID. Once online verification, a push is automatically sent to the from the company login process to the user's cell phone, and will immediately prompt for a user to take a selfie. Resilient ID will examine the selfie for liveness and bias testing, ensuring no one has attempted to provide a deep fake video or mask over the face or using a photograph. Resilient ID will then examine the selfie against the stored ID NFT, a blockchain-based ID which was created in the onboarding process. Once validated, the user will be granted access. Let's see how this works. The onboarding verification, again, is very simple. Or online verification is very simple. Once the user logs into the company site, the user will receive a push to the user's cell phone, will automatically prompt the user to take a selfie. Next, Resilient ID will examine the selfie for liveness and bias testing, and then validate the selfie against the stored ID NFT. Once validated, the user will be granted access. And you see here, they're granted access into the system. All right, Paul.
Yep. So now that Charles has showed you, go ahead.
No, I was just going to say, that was awesome. Thank you very much.
Yeah, now as Charles showed you the onboarding and the authentication of the user to make sure they are a user, I'm going to take you through what it looks like once we have all that information into the system and how you would actually access a protected service behind our trust zone. So I'm going to share my screen with you. And as soon as I get this working correctly, this is what it looks like as far as administrating the trust zones that we're talking about. If you look at our administrative console, which is what I'm showing you here, you're looking at what you would see as a typical dashboard. Now, my dashboard is very simplistic for demo purposes. It just basically shows your open and closed connections. But as we move from left to right, you'll see the other items as part of our administration console that you use to actually administer and actually deploy the solution. So moving left to right, we're going to go to our gateways next. As previously mentioned, our gateways are the first point in establishing your trust zone. They are our policy enforcement points. As you can see, I've got a trust zone set up. It's trust zone 20. We just randomly name them that way so we can reference them. The host IP, this is the public IP of the gateway. SPA port, if you remember SPA port, I mentioned a little bit earlier, SPA stands for single packet authentication. That is the stealth port that the gateway is listening to. Now, by stealth port, I mean that you cannot see that port. If you scan the gateway itself with an Nmap or a similar reconnaissance gathering tool, you will see nothing. You would bounce off that denial firewall because there's no policies open, there's no ports listening. We're able to implement this because we're able to listen for that port behind the scenes by doing packet sniffing and then actually act upon it once we've authenticated the device. Along with that, we define what services the gateway will protect. As you can see, I've predefined 4 services here that our gateway is protecting in my demo environment. RDP, which is the remote desktop protocol, a chat client, which is just a random chat client that might basically emulate what you might see with a Slack if you have developers in your environment. So basically a communication system that you use to collaborate amongst your teams. FileCam is a application we built in-house to essentially baseline your ability to actually implement FileCam in your environment. SSH obviously is secure shell, and Telnet, of course, is Telnet. So the last one is the gateway control that everybody's allowed to get. So everybody needs to be able to talk to the gateway. So obviously the gateway itself protects that port as well. If you wanted to add a new gateway to your environment, or by extension, you're actually adding a new trust zone, you just simply do that here. You add a gateway, you decide if you want to create a new one or you want to add it to the existing one. We're going to create a new one. You basically tell it what IP address that gateway is going to be listening at. Obviously, that's not a real gateway. I mean, that's not a real IP address. We're just using that for demonstration purposes. And then you tell it what port it's actually going to listen to for that SPA packet. So if we just say it's SPA packet, they're going to be listening on that, and it's a valid gateway. So now, just like that, we've created a new trust zone. Now, you can notice the lock in the credentials. We haven't actually defined anything for this trust zone, so there's no credentials and there's no configuration generated quite yet. Because after we decide what the gateway is going to be and what port it's going to be listening to, we actually got to define what services it's actually going to protect. So you do that here. Now, as you saw, I've defined these predefined services for our purposes of demonstration. I'll just reuse these, but obviously you can expand this list to anything you want. I'll show that to you later in our services menu. But let's just say that we wanted this gateway to protect 5cam, chat, actually 5cam, chat, and then we have to tell it what protocol that service is going to be using, what port that the gateway is going to accept. So let's say that the port that the gateway is going to be listening for connections over is 8080. This is the actual IP address of the hosted service in the trust zone. So this is where you have your non-routable IP defined for your service, for your host that's actually retaining your service and running it for you. And then what port is that service actually listening to on that host? So 8080 I can accept at the gateway, but at the back end I can say that the service is actually listening to port 3000. And then we say how we're going to get it there. In our architecture, you're allowed to put the gateway directly on the host itself. So you can do a host by host protection, or you can actually do it as a gateway, as the name suggests, and put it in front of multiple hosts. So in this case, we're going to say it's a remote. That means it's multiple hosts. There's multiple hosts behind it. I'm not sitting on that gateway. And then I'll click save. Once I click save, you can see now this is a service that now is being protected by Trust Zone 118 and by this gateway listening to this spot port. You can add other services as well. You can do, let's say we just do the 5cam service. Same deal. We can just say whether or not it's TCP, what port it's going to listen to. Let's say they're going to listen to port 80 up front. He's going to be on 7172.0.1.5, whatever. And then, but on back end, he's actually listening to 8080. So we can actually say, we can actually just determine what port is accepted at the gateway and what port's redirected on the back end. And then again, we can say whether or not we're sitting on the actual host, we're just protecting one single host, or if we're actually a gateway and we're protecting multiple hosts in the trust zone. So again, we did save, and you can see that's added. Once you have that added, you can then say, all right, now I'm ready to go. The idea is that you have a gateway out there already provisioned, it's ready to go, but you just don't have the configuration for it, or you don't tell it, and it doesn't know what is protected yet. So that's where this comes in. You basically generate credentials. You now generate credentials for this gateway. Once you generate those credentials, now you have the capability of copying that URL and supplying it to the end user, so that now they can pull down a zip file. That zip file is placed on the gateway itself. The gateway knows what to do with that zip file. It unzips it, it reads its configuration, and then it's online. So that's how you administer gateways and setting up additional trust zones in the environment very easily through our administration console. Moving to the right, we go to our users. Right now, I have a static users defined in the system. The idea, if you remember the concept of, not only do we make sure that you're a live person and you are who we think you are, and you backed it up by documentation, a passport or other government ID, we need to know that you're actually part of the system that we're protecting. So in this case, we would actually tie into your Active Directory or your LDAP server to be able to determine whether or not this user who's asking for access to a service is actually part of your organization. Again, for our demo purposes, I have it set up locally, but in production, it's actually connected to an LDAP server / Active Directory server. Devices. These are the actual endpoints. These are the endpoints that we actually define that are allowed to access the system. And you can see, for our demo purposes, I've set up 2 services. We'll just work with one, mine, the one that's been assigned to me for Trust Zone 20. And you can see that we decided what name the client is, the MAC address of the device to make sure that we know what the device is, the type of device, it's desktop, laptop, mobile device, etc. And then who the user is. And again, this can be added on the fly. We have APIs that allow bulk onboarding, so you don't have to do one by one. But essentially, it's the same as the gateway. You add a device, you decide what the device's name is. You give it the OS. It's a Windows OS. It's we'll say we're actually running 11. And then the MAC address, again, this is the part as part of the device onboarding. Obviously, we would do this on the fly. We would have to do this as part of the onboarding process for the endpoint. But it's the same deal. You basically set up your MAC address. And of course, it does. I'm not going to do a real one here. I just want to show you how it works. And then you say what type it is. It's a laptop. It's doing error checking on me. Then who's going to do it? It's going to be me. What gateway do I want to use? I just created one. I'm going to use that gateway. And then I'm going to create a new client. And then you do save. Now you can see now all of a sudden I've got my MAC address. I've got my device name. I've got the trust zone that I'm going to go to. But the device itself or the agent that's running on that device has no idea about that information yet. He's just ready to go. So again, once you define the device, you can now generate the credentials. What the credentials does is it gathers up all the configuration, all the encryption keys, all the certificates that you need to communicate to the system, and puts it in a nice zip file that can be then transmitted to the user or downloaded automatically from the agent. So we generate credentials, we do the same thing. And again, you're presented with a URL that you can then use to SMS to the user, push down by policy, or other means of delivering that configuration to the user. And again, once the user has that configuration, they place it on their endpoint system. They launched our agent, the resilient agent, zero trust agent, and it knows exactly what to do with that zip file. It unzips it, it sucks into its own configuration and has everything ready to communicate with the system. Services, as I alluded to earlier, this is where you define the services that are available in your system as a whole, not just per trust zone, but as a whole. Again, and for my purposes, I've just defined these 5. The 2 at the top, everybody gets, so those are always included by default. But these other 5 are at your discretion, depends on what you want to protect. And then finally, we get to the part where I alluded to earlier, where the controller or the administration console is where we define our enforcement policies. You can see by what I've got set up here, my client, I've already got set up, and I'm allowed to enter that, basically access that chat service. Think of it again as that Slack service that maybe your developers are using, or maybe your other people are using for collaboration in your environment. So I've already said that this guy is allowed to do that. Again, everybody has to talk to the gateway, so the gateway services is always allowed. And then you can see on the second one, I've got this one set up since the Windows client to do RDP. So that's exactly how you set up and administer the environment. From here, you've set up the environment, you're running. What I want to show you next is exactly what it looks like to use the technology. Now, what I'm going to show you is underneath the covers. It's not expected to be user-friendly, but it's expected to actually drill home the point of how it works in the background so that you can understand it a little easier than just seeing me click some magic buttons and have everything happen. So that's what I'll show you next. So essentially what we're looking at is a Linux environment, agent that I've got set up in my environment, ready to go. You can see in the windows in the background, if you noticed, they're kind of small, but if you can call out, you can see the numbers, you can see my client ID, and you can also see the trust zone ID, health checking. So we know that these are alive, we know that they are responding, we know that they're ready for work. At the bottom, you can see a little bit more information that you would ever see in production, but I wanted everyone to see it. This is the enforcement point. This is the actual gateway waiting for messages to actually permit or deny access to certain areas in the environment. Now, what I've got set up is Rocket Chat. And Rocket Chat again, it's just a chat service that you might use to collaborate with in your environment. And what I want to show you first is that chat client has no way of getting there right now. So if I access the chat client tunnel, which is this, you can see that it's having a problem getting there, and you would expect that. This is the actual connection string here. And you would expect it to have a connection denied or not knowing what to do with the connection because I haven't requested it yet. So what I'll do now is now that I've shown you that the access is not permitted, it's not capable of getting there, what I'll do now is I'll actually request that. So if I go here to my window, and then again, understand that this is not intended to be user-friendly. It's meant to show you details of how the system works. I know for a fact that service number 5 is my chat service. So I have to ask for that before I'm able to get in. And as I've shown, I'm not able to get there yet. So what I'll do is, and I want you to pay attention to these 2 windows on the back end after I do it, is I'm actually going to request access to service 5, which I know for a fact is chat. And what we'll do is we'll notice that it'll tell us whether or not we had access or not. So here we go. I just accessed it. Here's our enforcement point, waiting for the connection request. And as soon as it gets it, we'll get an access request to give us the permissions that we want. Hello. Susan,
We do have a question when you're ready, Paul.
Okay, all right. Give me a second.
Yep.
So what we're waiting for is access granted. I'm running on, on my home system, so we may be getting some delay here. We can do a question now while we're waiting for this to happen.
So Humberto is asking the question, I assume that the configuration of gateways is software that runs on some cloud infrastructure, ? Or are gateways with which in Zero Trust Network is configured, and how are multi-cloud and hybrid scenarios considered? Great question, Humberto.
Good question. We support both. Right now, what you're seeing is the major infrastructure is running in my AWS cloud account. So the controller and the gateway are actually in the cloud, and my client is actually running here at my server in South Florida. So let's see. I ran multiple tests this morning. It should be fine. And we're getting health checks. We're fine. Let's do it again.
And if you do have any other questions or anything else, just pop that in the Q&A. We'll make sure we get that to you. And we know that we're running up against the time in just a minute. We'll get everybody out of here in just a minute. This is being recorded so that you can have a copy of it as well. And you can see it afterwards, pass it on to the rest of the folks that weren't able to make it today. And you'll have a copy of the video along with it. So you'll have the presentation, the video, and all the handouts as well.
Yeah, give me 1 second to troubleshoot. We should have gotten it by now. Entertain yourselves for 1 second, if you don't mind.
So we did have a couple of other answers to our question, which is where you're from and what is your favorite Thanksgiving food. So I'll go right back to that. We have mashed potatoes and gravy, sweet potato casserole from James, and creamy mashed potatoes. Gotta love that, Jennifer. So there you go. There's your update and stall for time cover for you there, Paul. How you like
Good
that?
work. Good work. Give me 1 second. I just need to check a couple vital things. I want to make sure when I bring you back, we're actually here.
That's fine. While we're doing that, we can just talk about, so everybody can pop out if they need to, what to look for in a zero trust solution. Charles, let's talk about that while Paul's doing the back end. You know, this is live. Everybody knows this wasn't canned now because Paul's doing triage. There you go, Charles.
Appreciate that. So Zero Trust is a framework. There's no one application that's going to solve everything. And as you saw in the government 7 pillars architecture, there are a lot of requirements to be able to fulfill if you're depending upon the level of requirements that you have within your organization for security. But you absolutely need to be able to cloak sensitive applications and services. You need to ensure that those services that are only visible and accessible to authorized end users. Mm-hmm. Security framework for protecting critical applications and access needs to be absolutely a zero trust solution. ICAM can't tell you how important it is on the front end to absolutely ensure the user is the actual user that you want to have access into your applications. Truly a core foundation of zero trust. The premise of never trust always verify before granting access. It has to be the mantra of the organization. You cannot use trust but verify. That is unfortunately has proven to be a false capability. And then after authentication, open a separate encrypted data plane for data transmission between the end user and the protected assets themselves.
And Humberto is asking the question, resilient connectivity made more efficient in some way to reduce delays, or is it only encrypted and micro-segmented?
It's only encrypted and micro-segmented. We don't do anything for compression or try to increase or decrease bandwidth with the connection. We just secure it.
And you about ready, Paul? I'll launch this poll real quick if you're not.
Go ahead and launch the poll if you don't mind. It's peculiar. Let's say peculiar for now.
Yeah, there you go. IT stuff. So if you'd like to continue the conversation, let us know. If you need help with any of these parts, with meeting the presidential memorandum, always an issue for most agencies anyway. Are you want to be included in the next briefing? I'm interested in a proof of concept. Please schedule a presentation for your team. That would be with you, Paul and Charles, to talk about that. Or please contact me. And when do you want that to happen? Don't want to drive you nuts. We just want to make sure that you have what you need in order to continue the conversation, because everybody here has got to meet those zero trust mandates, right? We're all in this together, trying to solve that problem, right, gentlemen?
That's right.
You got it.
You bet. So we'll make sure we get this information passed on, and I'll go ahead and stop. Let me say this. We'll say this. You can pop stuff into the Q&A if you need to. Otherwise, make sure you reach out to them. We did have a couple of things about please address how organizations implementing zero trust with no additional funding. Very big problem here, guys. Joshua, that's above my pay grade. I'm not sure these folks here can answer that question either. Very hard to do with no additional funding. There are dollars and cents that need to be applied, as we all know. A Marine from the EPA, how to convey zero trust practices to a service center in your own organization that you're not part of. Very good question. That's why we do these briefings, so that you can collect the information and make sure the folks that you're not part of, who's ever in charge of implementing those zero trust practices, are part of that. Mishaela from NIST, taking the ZTA implementation challenge to a multiple cloud solution. We just talked about some of that, right, Paul?
That's correct.
Multi-cloud solution. It is possible to do. And my recommendation is that you schedule a time with these folks to talk about, dive down in detail. Obviously, with NIST, you may have a different aspect of this that you're trying to help other agencies as well. Edgar, what architecture views do I need? We talked about some of those. Edgar will reach out and make sure you get those, right, gentlemen?
Yes, absolutely.
And Jonathan from Education, ZTA for the smaller budget and employees IT groups. This is scalable across multiple ways, right? That's one of the things we're talking about too.
Correct.
Completely scalable. Yeah,
completely scalable. Fantastic. Well, I'll keep that poll open. You ready to rock and roll again?
I've had a catastrophic failure in my communications protocol with AWS.
There you go. We'll blame AWS for the moment.
Yeah, I used up all my lucky charms apparently on my prep for the webinar. I apologize to everyone. I don't know I don't think I can get it working in the next couple of minutes.
All right. Well, then what we'll do is we'll make sure that they do that with you individually. How about that?
And then this is a working system. This is not a candy demo or anti-smoke and mirrors. Please follow up with me if you want to see it actually work.
There you go. By the end of the day, you will get the briefing presentation, links to the session docs, which you already have actually, but you also get a link to the video so you can watch it over and over and over for its educational and performance aspects. You also talk to these guys one-on-one with that. You can answer it there in the conversation right now with the poll, or you can click and schedule a meeting with them. We just want to say thank you so much for joining us, guys. It's great. Great to have you here. And as well as you folks from Resilient. And we definitely, if there's anything else that you need, pop an email to dmorris@resilient.com and you will get answers. I am certain of it. So we're going to let these guys out of here. Any parting comments for anybody else? Let me make sure there's nothing else here. Humberto says thanks. And from Colombia. Love it. Appreciate that, Humberto. Great questions, by the way. And we appreciate you guys joining us. Anything else you guys want to say before we let everybody out of here?
Just want to thank everybody for their time, and if there are any follow-on questions, we're more than happy to answer them for them.
Yeah, absolutely. And again, apologies for the snafu on the demo, but it's a live working demo. We're able to show that anytime once I figured AWS issue out.
You can go smack AWS around a little bit. Folks, thanks again for joining us for this interagency briefing. We'll have some additional information popping out that you can take a look at as well. We appreciate you joining us. Thanks, guys. Great job. Hey, and you always know that it's live, right, Paul?
Absolutely. You know, daggone well it's live.
That's right. Doggone well. All right, guys. Happy Thanksgiving if we don't hit you before that.
All right. Thank you, guys.